Yes, very good morning to one and all. Fine. Before getting into today's session, we will go with the previous content. Okay, previous session content. So in the previous session, we have discussed about the branching group of instruction. Okay, then difference between jump and the call instruction. Can you people type it in the chat? What about the difference between jump and the call instruction? In both jump and call instruction, we will mention an address, correct? JMP address, call address. What is the difference between jump and call? Yes? Kindly type it in the chat. Sajesh typed RET instruction. Okay. What it means, Sajesh? What about others? See, jump instruction and call instruction is difference. Jump instruction jumps to that address. Very good. And what about call instruction? The program execution is transferred to the mentioned address when we are using jump instruction. What about call instruction? Yes, Danya typed one more answer. Jump is used in single code. Call can be used to call a subroutine. Fine. Okay. Yes, very good, lovely. What I have expected, you have typed in the chat. PC content is stored in the stack memory, whether in jump or call. Lovely, you have typed in jump. PC content is okay. PC content is not stored in the stack memory. Very good. Logus Nega typed PC content is not stored in the stack memory in jump, whereas in call it does. Very good. Very good. That's the correct answer. Okay. See, the return address will get stored during the call instruction in the stack memory. Correct. So when we are using the call instruction, it is transferring the control to a subroutine program. Correct. So at the end of the subroutine, what we have to do? What we must do to continue the main program? What we must do at the end of subroutine? See, when we are using the call instruction, it is transferring the control to the subroutine program. Fine. At the end of subroutine, what we have to do? Yes, we have to write return instruction at the very last line. Correct. The last instruction in the subroutine must be a return instruction. Okay. Whether we need to specify any address along with return instruction. In the case of jump call, we are specifying the address. What about in the case of return instruction? No, we no need to specify the address. Why? Whenever return instruction got executed, what will happen? How it know the address, where it has to return? Yes? Yes, by default, when we are using the call instruction, the return address gets stored into the stack memory. So when return instruction got executed, it pop out the return address from the stack memory and go on to execute the particular, continue the main program. Correct? Fine. Then we have gone with stack instruction. Okay. What are the two instructions we use to put content into the stack or to remove the content from the stack? Stack instruction. Yes, push pop. Fine. Apart from that, we have one more instruction which will load stack pointer register with HL register content. Yes. Yes, PHL. Very good. Then we had two input output instruction to perform the data transfer between input output device and microprocessor. Okay, we are having two instructions, dedicated instructions. What are the two instructions? Yes. In, out, very good. What about the full format of the instruction? Simply whether we have to write in or we have to mention something. Yes, in 8-bit device address, P8, correct? Similarly, for out instruction, we have to mention the address. Fine. See, when we are using this two instruction, which register must be used to transfer the data between microprocessor and IO device, which register is used? Yes, very good. Accumulator register. Very good. Super. Fine. Then we have gone with the machine control instruction. Okay. So out of the 6 machine control instruction, we are using one of the machine control instruction in our lab program. Correct? The 3 lab experiment we specifically used one machine control instruction. Can you people type it in the chat? Yes, very good, very good, very good. HLT, alt instruction. Okay, fine. So then we have introduced the machine cycle and timing diagram topic. We will continue on that. Fine. So today we are going to continue with machine cycle and timing diagram. Okay. We have to know what is a T state. Correct. The T state refers to the time interval between successive rising or falling edge of the clock. Correct. See, rising edge means from low to high when the signal is transferring. That we call it as rising edge. Falling edge means when the signal is transiting from high to low. That we call it as falling edge or negative edge. Correct. The time interval between the consecutive rising edges or falling edges, that we call it as T state. Simply we can say time period nu padichirukkom. Oru waveform oda time period appadina enna solluvom, oru cycle ku undana time. Correct. The same thing here also. Fine. To have some reference, we are denoting the time interval between the successive rising edge or falling edge like that. Clear? Okay. If my microprocessor is operating at 2 megahertz, you assume my microprocessor is operating at 2 megahertz. What about the time period of the pulse? Can you people type it in the chat? Frequency on the 2 megahertz. What about the time period? Yes. What about the time period? If my microprocessor is operating at 2 megahertz, what about the time period? Anthony Surya 0.5 mega, or what it mean? Yes. Yes, 1 by 2 mega. Sajesh, you missed mega. Okay. See, 1 by 2 is 0.5. That's fine. 0.5 microsecond. Very good. Very good, Anthony Surya. Fine. So T is equal to 1 by F. You consider now the frequency is 3 megahertz. Okay, now you consider the frequency is 3 megahertz. The typical operating frequency of 80-85 microprocessor is 3 megahertz. Correct? So in our trainer kit also, it operates at the frequency of approximately 3 megahertz. Fine? Exactly, it operated 3.072 megahertz. Fine? So here, if the frequency is 3 megahertz, T is equal to 1 by F. So T is equal to 1 by 3 mega, 3 into 10 to the power 6, which becomes 0.33 microsecond. Okay. See, you will be given some problem during your exam. Okay. You will be asked to calculate the T state, time period of a particular clock pulse. Okay. What is the value of 1 T state? If the microprocessor is operating in this megahertz, like that, you will be having some question. Okay. So at that time, you should be able to answer. Fine. So T state is nothing but the time period of the pulse, clock pulse. Okay. So 1 T state means the time period of 1 clock pulse. 2 T state means time period of 2 clock cycle. That's all. Fine. So now we are going to continue with the machine cycles. Okay. So before that, we have to know a few terms. Fetch cycle. Okay, fetch cycle. Fine. Here it means the time taken by the CPU to fetch an instruction from the memory and decode it. Please kindly observe. Okay. So inge nama fetch cycle appdin sonnamna 8085 microprocessor பொறுத்த வரைக்கும் is the time taken by the CPU to fetch an instruction from the memory, okay, and decode it. Generally, in the fetch cycle itself, the microprocessor do the decoding operation. Okay, we will later see how it is done. Fine. So fetch cycle அப்படினா என்னன்னு புரிஞ்சுதுங்களா? When we are writing some program, okay, the programs are formed with instructions. each instruction it is going to have opcode and operand, correct? The first byte of every instruction must be what? The first byte of all the instruction must be what? Yes, very good, opcode, correct? The time taken by the CPU to fetch the opcode, fine, that we call it as instruction, fetch the first byte of an instruction from the memory, that we call it as fetch cycle. Clear? See, there is a difference between fetching opcode and fetching a data. There is a difference we are going to use. Fine. Fetch cycle means the time taken by the processor or CPU to fetch the opcode from the memory. Correct? Here we mentioned as instruction. Here instruction means the first byte of the instruction, that is the opcode. Okay, and decode it. The total timing we call it as fetch cycle. Fine. Then execution cycle. The time taken by the microprocessor to perform the operation for the instruction. Say for example, add B, the time taken by the processor to fetch the instruction and decode it. Other fetch cycle, the time taken by the processor to execute the operation. And the addition operation perform time in execution cycle. The time taken by the CPU to execute the prefetched instruction, that we call it as execution cycle. Okay. In total, the combination of fetch cycle and the execution cycle combinedly we call it as instruction cycle. That means the time taken by the CPU to fetch, decode and execute an instruction. This entire duration we call it as instruction cycle. Clear? Are you able to understand what I am saying? The time taken by the processor to fetch the instruction, decode it and to execute the operation. The entire time we call it as instruction cycle. Fine? Okay. So you can see in this diagram. Okay, this entire thing we call it as instruction cycle. Totally we are having 7 clock pulses. 1, 2, 3, 4, 5, 6, 7. Fine? So totally we are having 7 clock pulses. Okay, so this 7 clock pulse is divided into 2 cycles. 4 clock pulses for fetch operation and 3 clock pulses for execute operation. Correct? See, here it is mentioned for an example. Okay, all instruction ku ide timing na abin ketta kediyadu. Clear? Some of the instruction will take 10 T state. Some of the instruction will take 13 T state. Okay, here for example we are denoting instruction cycle. Okay, it's a combination of fetch cycle and execute cycle. Clear? So fetch cycle here in this example it takes 4 clock pulses. That means it takes 4 T state. Like that we have to say. Fine. So here for execution it takes 3 T state. That means I will ask a question now. What is the duration of fetch cycle in the given diagram? Can you people type it in the chat? How many T states fetch cycle? Yes, very good, very good. Anthony Surya Shivakumar, very good. How many T states it takes for fetch cycle? Yes, 4 T state, very good. Fine. What about the timing for execution cycle? How many T states? Yes, very good. What about the timing for instruction cycle? Yes, very good. Very good, very good. 7 T states, that's all. Fine. See, the execution of the fetching operation, decoding, execution, the whole part is, we call it as the time taken by the processor to execute an instruction. Clear? See, when the processor is executing an instruction, it do several operations. Fine? Taking the output from memory is one operation. Okay. Reading the data from the memory, it's one operation. Or writing some data to the memory, that is one operation. Like that, several operations takes place when an instruction is getting executed. Clear? Clear? That we call it as mission cycle. The next slide we will go with it. So instruction cycle equal to fetch cycle timing plus execution cycle timing. That's all. Fine. So now we will go with mission cycle. So the time taken by the CPU to complete an operation of accessing either memory or I/O. See, when we are discussing about the status signal, we have mentioned what is meant by mission cycle. you can refer that. You can refer and tell. What are the different mission cycle we can have? You can refer and tell. Some of the mission cycles are listed here. Not all are listed here. Some of them are listed here. Okay. For example, opcode fetch cycle. Okay. That means this particular mission cycle, during this particular mission cycle, the microprocessor is fetching an instruction and decoding. Correct? Then memory read cycle. It is the time taken by the processor to read a data from the memory. Fine? That we call it as memory read cycle. Memory write cycle. It is writing some data to the memory. Okay, that we call it as memory write cycle. The same, if it done with input output device, we can have IO read cycle, IO write cycle. Okay, so 5 mission cycle we have listed here. Apart from that, you have many mission cycles. Okay, few other mission cycles you are having. Okay, interrupt acknowledge mission cycle. Okay, that is one type of mission cycle. Bus idle cycle, something you have like that. Bus idles. Okay, so similarly you will be having few more mission cycles. Fine, we will go one by one. First, we will go with opcode fetch cycle. Shall we proceed? Is there any doubt still now? இதுவரைக்கும் நம்ம சொன்னதுல ஏதாவது டவுட் இருக்கா? ஒரு இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் ஆகும் அப்படின்னா several operation, one or more operation, not several, one or more operation takes place in the instruction to execute the instruction. Fine, that is divided into different mission cycle. Okay, so in such a way it is classified as opcode fetch, memory read, memory write, IO read, IO write, etc. Fine. So now we will go with opcode fetch mission cycle. Fine. To execute any instruction, what the microprocessor has to do first? To execute any instruction, what the microprocessor or CPU has to do first? எந்த ஒரு இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் பண்ணனும்னாலும் ப்ராசஸர் ஃபர்ஸ்ட் என்ன பண்ணணும்? Where the instructions are available? Where the instructions are available? Where the instructions are stored? Yes, very good, Anthony Surya Shivakumar. Definitely, the instructions or programs are stored in the memory. Correct? Fine. The first thing to execute an instruction is it has to fetch the opcode of the instruction. Correct? So that is the very first mission cycle during the execution of all the instruction. எந்த ஒரு instruction execute ஆகணும் அப்படினாலும் the first cycle, the first mission cycle must be opcode fetch mission cycle. Fine. Very good. Few of you answered. I think Danya answered. Addressing. Shivakumar answered. Addressing. Yes, very good. So to take the opcode, to fetch the opcode from the memory, first it has to send the address. Correct? See this diagram. The opcode fetch operation involve the following steps. First, it has to send the address of the instruction. Where the address will be stored? Where the address of the next instruction will be there? Yes? Any idea? Address of the instruction, who will be having the address of the instruction? Yes, very good. Program counter. Very good. Program counter. Correct? So the address of the next instruction to be fetched, fine, that is available in program counter is sent, okay, to the memory device. Fine. Next, what the processor has to do after send the address, what the processor has to do? That particular memory location is enabled. Correct? Sorry, that particular memory location is selected. Fine. To fetch the opcode, what operation the CPU has to do? The memory lane நம்ம என்ன பண்ணனும்? opcode fetch பண்ணனும்னா whether it has to read or write something. Yes, very good, very good. So after send the address, the opcode is fetched from the memory by generating the read signal. Fine. Processor என்ன பண்ணும்? Read signal generate பண்ணும் such that the address memory location content, that is the opcode, is coming into the database. Correct? That particular thing is transferred to the instruction register. These two things, fine, The opcode is fetched from the memory to the data bus and it is transferred to the instruction register. For this two things, it takes 2 clock pulses. Gets opcode from the memory location to the microprocessor. That happens in the next 2 clock pulses. Okay, here you can mention, here it can be mentioned as T1, T2, T3, T4 like that. You assume each T states are mentioned with a naming such that T1, T2, T3, T4. Okay, sending the address happen in T1 state. Okay, the opcode fetch takes place during the T2 and the T3 state. Fine. Now the instruction is available in the microprocessor. Okay, whether the microprocessor know what it has to do. Opcode vechittu processor ku enna pannum theriyuma? What it has to do? After getting into the instruction register, what it has to do? CPU enna pannum pa instruction edutittu vandachu. What is the meaning for that instruction? It has to know. For that purpose, very good, super. It has to decode. Yes, it has to decode the particular opcode. Correct. So that takes place in the T4 state. Okay. Sorry for not mentioning the name of each T state. Okay. The first clock pulse, it is mentioned with T1. The second one is T2. Third one is T3. The last one is T4. Wait a minute. Wait a minute. I will mark it. So T1, okay, T2, T3, the last one is T4. I think, is it visible to all of you? T1, T2, T3 and T4. Fine. So this we call it as the opcode fetch mission cycle. Fine. To execute any instruction, the microprocessor has to fetch the opcode first. Clear? The first byte of every instruction is opcode. Correct? That particular operation we call it as opcode fetch mission cycle. The time taken by the CPU to perform this particular operation, that means to fetch the instruction and decode it. Even though decoding happens in the fetch cycle, it is mentioned as opcode fetch cycle only. Opcode fetch mission cycle, or simply you can say opcode fetch cycle. Clear? Is it clear for everyone? Is it clear for everyone? Yes? Okay, fine. Then one more point, the instruction which have only opcode fetch mission cycle. Okay, some of the instruction, okay, say for example here it is mentioned as move A comma B. This particular instruction you consider. Fine, it will be having only opcode, correct? The instruction which have only opcode fetch mission cycle, what it do? First 3 T state to fetch the opcode. Okay, the last T state to decode and execute the opcode. Correct? See, and the particular opcode execution pandradhukku last state le mudiyalam. Fine. If the very important thing is if operands are from internal registers. What it mean? In the operation perform pannum CPU understand panna adutha nimisham. Okay, the next instant, at that instant, it knows where the operands are from. Okay, if it is from memory, it cannot be done in the 4th T state itself. Okay, now here you consider this condition, move A comma B. What it has to do? What it has to do? What is the meaning for this instruction, move A comma B? What is the meaning of this instruction, move A comma B? Kindly type it in the chat. Move A comma B na enna meaning? The data from B register has to be copied to A register, correct? Fine. What about the data or the operand present, where the operand is present now? Operand எங்க இருக்குது? Which type of addressing mode this one is? Which type of addressing mode? Yes, register addressing mode. The operand is addressed with the name of the register. Where the registers are located? Inside the CPU or outside the CPU? Yes, very good. Fine. Allah கவனிக்கணும். Opcode fetch பண்றதுக்கு 1, 2, 3. Fine. The fourth T state to decode the after decoding, if the operands are internally present in the registers, it will execute in the T4 state itself. Clear? So move A, B instruction பொறுத்த வரைக்கும் it has only opcode fetch cycle. Okay, whole instruction will get executed in the opcode fetch cycle itself. Is it clear for everyone? It is not for all the instruction. If the resources, the data are available inside the CPU, it happens with no time. Execution happens in no time. Okay, that's why in T4 state itself, the execution also finished. Clear? This is for only few instructions. Few instructions which is having internal operand. Fine? Okay. Now, this particular mission cycle, okay, this particular mission cycle can be understand. Okay, so for that we will be going with a timing diagram. Okay, so what is meant by timing diagram? We are going to have a pictorial representation of all the signal with respect to a time. Okay, so it's a graphical representation of all operations involved in a mission cycle as a timing diagram. Okay, that is called as timing diagram. Okay, with respect to time, okay, which signal we can use it for reference as time? In the signal time reference use usually? Which signal can be used as a time reference? Very good. Shivakumar, Anthony Surya typed. Clock signal, correct? Fine. So we have some convention method of drawing the signals in the timing diagram. Timing diagram la இந்த மாதிரி வரைஞ்சிருந்தோம்னா அதுக்கு என்ன meaning? Few conventions we are having. Okay. To represent the signal transition, that means high to low எனக்கு signal change ஆனிச்சு அப்படின்னா there will be a notation like this, convention like this. Clear? So line மேல இருக்குது, fine, it is dropping down and it is maintaining. So this portion we call it as logic high, this portion we call it as logic low. In other words, we can say it as falling edge or negative edge. Clear? The signal transition from high to low. I think somebody unmuted and speaking. From classroom 2, I think. I don't know whom.
Now they have.
Okay. Fine. Similarly, the signal transition from low to high. Fine. This can be termed as rising edge or positive edge. Okay, the signal is changing from logic low to logic high. Fine. See, in this way, it can be represented in the timing diagram. And the signal is changing from one state to another, either from 1 to 0 or 0 to 1. Okay, it should be mentioned like in the diagram. Then, bus transition. Okay, we all know bus is not a single signal. Whereas in the case of this diagram, it is single signal. In the case of bus transition, okay, single signal can change from 1 to 0 or 0 to 1. Fine. What about the group of signals? Group of signal na eludhirappa 8 line irukum. Data bus na ethana line irukum? 8 line. What about the size of address bus? What about the size of address bus? Yes, 16 line. Yes, it is very complex to mention the state of all the signals from the address line or data line. That's why we are using this convention, bus transition. That means you have to use a broader lines. That means group of 8 lines. It represents PCH, I think. Yes, the higher order address bus that is going to have 8 lines. Higher order address bus A15 to A8. 8 lines. It is combinedly mentioned like this. So in the broader line, நம்ம வரைஞ்சிட்டு என்ன பண்ணலாம்? here we can mention what is available in the bus. Higher order address bus la enna irukku PCH, program counter oda higher byte, it is transmitting, correct? Bus transition அப்படினா என்ன சொல்றோம்? See, here we are mentioning from high to low or low to high, but here in group of signal we have a transition like this. ஒரு cross மாதிரி மார்க் பண்ணிருக்கோம், கரெக்ட்டா? Signal change happens here. பஸ்ஸோட கண்டென்ட் இந்த இடத்துல எனக்கு என்ன ஆகுது, சேஞ்ச் ஆகுதுன்னு அர்த்தம். ஃபைன். ஸோ டியூரிங் திஸ் பீரியட் இட் இஸ் ஸ்டேபிள். ஓகே, ஐ எம் பாயிண்டிங் வித் ஏரோ, கரெக்ட்? ஸோ ஒரு டிரான்சிஷன் முடிஞ்சதுக்கு அப்புறம் till the next transition happens, the data available in the bus is stable. Fine. During the transition it will not be stable. Okay, it takes some time to get into the stable state. Clear? So that is marked with X. Clear? This we call it as bus transition. See, single signal na low length high pola illa high length low varlam, correct? Group of signal means it is complex to mention all the signal with single lines, correct? So the entire or the group of 8 lines or 16 lines can be combinedly drawn like this. It's going to carry an 8-bit data, that's all, or 16-bit data address, correct? So the transition can be marked like this in the timing diagram. Clear? Okay. Next. So in the case of single signal, we already know logic 0 to logic 1. Okay. If there is no space to maintain, that means, say for example, if a signal is high for 10 clock pulse, it is difficult for us to draw the timing diagram, maintain high for 10 clock pulse. So it can be mentioned with some breaking lines. Okay. So in the mari nama draw pannona meaning enna? It is maintaining for a certain duration which cannot be conveniently mentioned in the chart, correct? Fine. Then here you can see one thing. The signal is neither at logic 0 nor at logic 1. Here you can see tri-state, that we call it as tri-state. Fine. On reset, some of the signals are getting tri-stated. We have studied in the control signals, correct? Tri-stated means the bus lines or the lines in, or the signals is having neither logic 1 nor logic 0. 0 voltage irukadu, 5 volt irukadu. Fine. You will be having some floating value, that we call it as tri-state. Bus get tri-state or signal get tri-state. That's the meaning for that. Fine. Next. So already we have told about this group of signals can be mentioned like this. This particular thing, this X mark can represent a state change, a value change in the bus. This can be a valid state. Fine. The cross mark முடிஞ்சதுக்கு அப்புறம் திரும்ப next cross mark ஆரம்பிக்கிற வரைக்கும் valid data is present in the group of lines, correct? Then busல எப்படி tri-state represent பண்றோம் அப்படினு பாத்தீங்கன்னா with dotted lines. Whereas in the case of single signal, in between logic 1 and 0, if the line is maintained, that we call it as tri-state. In the case of bus, it can be mentioned with some dotted line, high impedance state or tri-state. Fine. Data change indication. Data change indication. Nalla gavanikanum. Here in this example, you can see ALE high irukku. So on the time la address varudhu. Fine. Next read signal enable, correct? Read signal is there, it is getting enabled at this point. Fine. So in the time la automatically namak enna varum data bus la the data read through the data lines. So in the particular timing la irundhu till the read signal get disabled. Eppa disable agudhu? When it is changing from low to high. When high to low, when it is maintaining at low, the data is available in the bus, okay, till the read signal gets deactivated. Read signal திரும்ப இப்ப எனக்கு ஹையா போகுதோ, so அது வரைக்கும் நமக்கு என்ன ஆகும்? The data is valid in the bus. Once read signal got disabled, the data becomes invalid. Okay, so this causes a data change or the value change in the group of lines. That's all. See, this kind of things you have to know. Okay, so these are some conventions we are going to use in the timing diagram. Okay, now we will go with the timing diagram of opcode fetch mission cycle. Timing diagram of opcode fetch mission cycle. Okay, fine, fine, very good. So here you can see what are the signals involved. As already we told, clock is the reference signal. It must be mentioned at the first. The clock is mentioned at the first signal. Fine. During opcode fetch mission cycle, the processor has to send the address. Correct. So here we mentioned the group of signal A15 to A8, higher order address bus, and AD7 to AD0. What it means? AD7 to AD0. What it indicates? AD7 to AD0 does enough. A15 to A8 is higher order address bus. What about AD7 to AD0? It is not A7 to A0 or D7 to D0. Yes, very good. Multiplex the lower order data bus and lower order address bus and data bus. Fine. The time multiplex the lower order address bus and data bus. Fine. In the previous class, I think Sir asked to Shivakumar. Okay, time multiplexing abdina ennu sir ketanga, correct? Shivakumar?
Yes, sir.
Have you found out the answer for that?
Yes, sir. Yes, sir.
Okay, at the end of this opcode fetch mission cycle, this particular slide, you have to explain why it is time multiplex, why it is termed as time multiplex. Fine? Okay.
Okay.
So now A15 to A8, here we mentioned this signal, and AD7 to AD0, we mentioned this signal. This 16 lines, that means this is one group of 8 lines, this is another group of 8 lines. Correct? So AD7 to AD0 is multiplex the lower order address from data line. Fine? Okay, then ALE is involved during the opcode fetch mission cycle. How? When we are addressing the memory, the higher order address line must carry the higher 8-bit or the higher byte of the address. The lower order address or the lower byte of the address must be transmitted to the multiplex line only. Fine. So to demultiplex the lower order address and data line, we need ALE. Fine. Then IO/M bar. This is status signal. It indicates whether the opcode fetch mission cycle is involving in memory or it is related to memory operation or IO operation. Then RD bar is the read signal to activate the read operation. Okay. Memory write signal, it is generated by the user externally for memory read operation. Okay. Memory read signal. Then combination of all the status signal IO/M bar, S1, S2. See, these are the signals involved during the opcode fetch mission cycle. Primary signals involved during the opcode fetch mission cycle. That's why we mention all these signals now. Fine. Now we'll go with the first clock pulse. During the first clock pulse, what the processor has to do in the opcode fetch mission cycle? Already we have explained. Yes, very good. Address the memory. Fine. So during the first clock cycle, clearly observe A15 to A8 higher byte of the address. Higher byte of the address. What about AD7 to AD0? It carries lower byte of the address or lower order address byte. Fine. It carries higher byte of the address. It carries lower byte of the address. Fine. At this point of time during T1, what about the status of ALE? What about the condition of ALE? Can you people see and tell? High. Very good. Very good. Fine. Fine. So what you can know now, during the first T state of the opcode fetch mission cycle, ALE goes high, such that the lower byte of the address is transmitted to AD7 to AD0 now. Fine. Where this value gets stored? Now ALE high ayiduchu, correct? The lower byte of the address enga poi store aidum during T1 state. See, the higher byte of the address, it is available in the higher order address line. Fine. In the case of lower byte of the address, where it will get stored? Yes, it will get stored into the latch which is enabled by ALE. Fine. Whether we generated ALE or CPU generate ALE. Yes, CPU. Whether it is time specific or not non-time specific. Now you can understand. Yes, it is time specific. During the first T state of any machine cycle, the processor has to send the address. Correct? See, in the instruction first opcode fetch and soliyach. Correct? Fine. The very first T state of the opcode fetch machine cycle, it is sending the address. At that point of time, the ALE is getting enabled high. What it means? So the address and data information are time multiplexed inside the processor. Fine. To demultiplex it externally, we are using a latch, okay, with enable signal from ALE. That's all. Shivakumar, can you answer now why it is time multiplexed? Shivakumar, your voice is breaking. Your voice is getting breaking.
Sir, now is it audible, sir?
Yes, now it is audible.
Sir, for every T state, the ALE gets altered, sir.
Ella T state
First
ko
we-
ALE high agaduma.
Sir, during first clock pulse, it has to
Yes,
reach
very good.
the
Yes, very good. During the first clock cycle of or clock pulse of any machine cycle, ALE goes high. Okay, such that the CPU can send the address, okay, and make the ALE high so that the lower byte get stored into the latch. Fine. Okay. The opcode fetch cycle. Now we will continue. The opcode fetch cycle, okay, is communicating with memory or IO device. From where it is fetching the opcode? From memory or IO device? From where? Yes, it is fetching the opcode from memory. So the status of IO/M bar signal is low. Fine. Fine. Okay, this signal is getting from high to low. You can see beginning of the T state. Okay, it is having some logic, some value. Okay. During T1 T state, it is maintaining low. Fine. That means during the opcode fetch cycle, the IO/M bar signal must be low by the CPU. Okay. It is a status signal. It indicates that processor is currently doing a memory related operation. Fine. Okay. Then RD bar is still maintaining high. Memory address பண்ணுது இருந்தாலும் read signal என்ன ஆகல இன்னும் activate ஆகல. So that memory read is also high. Fine. So in combination of all the status signal IO/M bar, S1, S0. Okay, can you people type it in the chat? What about the status of this group of signal? Status signal IO/M bar, S1, S0. Already IO/M bar na low nu solliten. Correct? What about the status of S1 and S0 during opcode fetch? Kindly refer that table and tell me. What about the status of the signal S1 and S0? Yes, very good, Anthony Surya. IO/M bar must be 0 and S1, S0 must be 1. See, here it is mentioned as a group of signal. That's why we are having a notation like this. Status signal அப்படின்னு சொல்றப்ப எல்லா சிக்னலும் கம்பைன் பண்ணியாச்சு. IO/M bar, S1, S0. That's why it is mentioned like this. Okay, செப்பரேட்டாவும் இங்க காமிச்சிருக்கும். As it is memory related operation, it is also specified in the timing diagram. Okay, fine. During T2 state, what happened? During T2 state, what happened? The higher order address is maintained in the higher order address line A15 to A. Fine. What happened to the signals AD7 to AD0 for this group of signals? What happened? Initially, what happened? You can see in the diagram. I have specified some dotted lines. What it means? Yes, ALE lower, low maintain. Correct? Yes, very good. Then yeah, tri-stated. The bus get tri-stated. Okay, for some time. Why it is happening? ALE low aids. Correct? ALE low aids. What it means? Now it is going to function as a data bus. Correct? The direction of the bus is getting changed. First address enachu from CPU to memory. Now the direction of information is from memory to CPU, correct? So for that transition, okay, it is maintaining with a tri-state. The bus get tri-state for a little period. Momentarily is tri-stated, correct? So once the read signal got enabled, read signal enable during the T2 state. Fine. Mid of the T2 state, the read signal is getting enabled. At that time, the memory read signal is also getting enabled. That means IO/M bar and RD bar. Memory read signal is generated. You refer that timing and control unit topic. Okay, memory read bar, memory write bar, IO read bar, IO write bar signals are generated by us externally. User B people are generating that signal. Okay, only RD bar, IO/M bar are from microprocessor. Memory read bar signal is generated by the user. Okay, so that is generated with the help of IO/M bar and RD bar. Fine. Now memory read signal got enabled. That means when the read signal got enabled, the opcode is coming into the data bus from the memory device. Correct? So you can see during the T3 state, the opcode is still available in the bus, so it is transferred to the instruction register. Fine. So it takes T2 and T3 state to get the opcode from memory to the instruction register. Fine. Correct. So the status signal remains same during the entire mission cycle. IO/M bar is 0, S1 is 1, S0 is 1. Fine. Is it clear for everyone? During the first T state of the mission cycle. The opcode fetch mission cycle, during the first clock pulse only ALE is getting high. Clear? What about the lower byte of the address? After T1 state, T2, T3 state, lower byte of the address enga irukku? The address is still available. Where the address? Yes, it is stored in the latch. Latch disable ana, input to the latch will be disabled, but the output will be available. Correct? So the higher 8-bit of the address is available in the higher order address line A15 to A8, whereas the lower byte of the address is available in the latch after T1 state. Okay. So now this AD7 to AD0 is functioning as data bus. So first T state la mattunda adu enna vaanichu, it behaves as address bus. The remaining T state, it is behaving as data bus. Fine. So the opcode is now available in the instruction register at the end of T3 state. Okay, the last T state, what it is going to do? What it is going to do? The higher byte of the higher 8 line, the higher order address line become unspecified. Okay, there is some reason for that. Okay, so during this particular time, the higher byte, the higher order address line are unspecified, and the lower order address and data bus become tri-stated. Okay, now the bus operation is not needed for the processor now during the T4 state. Fine. Once it taken the opcode, it is available in the instruction register to perform that particular decoding operation. It doesn't require the bus. Fine. So ALE is still maintaining low, IO/M bar is still maintaining low, RD bar gets disabled at the end of T3 state, so it is maintaining high. Okay, so the status signal IO/M bar S1 S0, it is maintaining the same status during the entire cycle. Correct? So the last T4 state, the decoding takes place. Fine. After decoding, if the operands are internal, it will do the execution also in the T4 state. Okay. Some of the instruction do all the things in the opcode fetch mission cycle itself. Okay. For example, I have told you move A, B. That particular instruction do all the operation in the opcode fetch mission cycle itself. Fine. Okay. So now it is mentioned. Now we can consider that example move A, B. So during the first clock cycle, that means T1 state, first byte of an instruction contain opcode. So the program counter places the address A15 to A8, AD7 to AD0 lines, places the address on those lines. Okay. So microprocessor activate ALE signal to latch the lower order address. So the MUP send the following status signal to indicate the opcode fetch operation. Fine. So these things happen in the first clock cycle. Okay. During the second clock cycle, what happened? The lower order address is latched in T1 cycle. So now AD7 to AD0 is ready to have data or output. Fine. So the MUP activates the RD bar signal and increments the program counter register by 1. Fine. Then third clock cycle. During third clock cycle, the MUP places the opcode on the instruction register and deactivates read bar signal. Fine. So the fetch operation is completed in the end of T3 state. Fine. So fourth clock cycle, it decodes the instruction. The execution takes place in this cycle itself as the operands are in registers. Internal operand move A, B instruction porthavarikum. The content is available in B register. It is an internal operand. So the execution also takes place in the fourth clock cycle. Okay. So that's all about the execution of the instruction move A, B. Fine. Is it clear for all of you? Is it clear for all of you? Yes. நம்ம எடுத்துக்கிட்ட இந்த இன்ஸ்ட்ரக்ஷன் பொறுத்த வரைக்கும் fetch, decode, execute எல்லாமே ஒரே சைக்கிள்லயே முடிஞ்சிருச்சு. opcode fetch machine சைக்கிள்லயே முடிஞ்சிருச்சு. Clear? Some of the 1 byte instruction. Okay. Some of the 1 byte instruction execution takes place in this manner. Okay. Now we will go with the timing diagram of memory read machine cycle. Okay. Memory read machine cycle. Okay. Memory read அப்படினா என்ன பண்ணணும்? Can you people type it in the chat? Opcode fetch க்கு நம்ம சொன்னதுதான் address send பண்ணனும். Okay, it has to generate the ALE signal during the T1 state. So address is latched into the latch. Okay. So the address is available after the T1 state. Correct? So next one, the read signal enable aanichu. Opcode is getting into the data bus. During the T3 state, the opcode is put into the instruction register. During the T4 state, it decodes the opcode. Okay, this is the opcode fetch cycle. If memory read operation, what are the things has to happen? To read a data from memory, what are the things has to happen? Memory la or data edukkanum appadina first what processor has to do again? In this memory read machine cycle also, it has to send the address of the memory location. Correct? So the same thing. So during the first T state, the higher byte of the address is sent through A15 to A8. Okay, the lower byte of the address is sent through AD7 to AD0. ALE is enabled. Okay, it is memory related operation. So IO/M bar, it is maintaining low. Okay, the read bar is not still active. The status signal, what about the status signal condition? What about the status of the signal IO/M bar S1 and S0 during memory read operation? Yes, very good, Shivakumar. 0. IO/M bar is 0. S1 1, S0 0. Very good. Very good. Very good. Fine. So that's about the status signal. What about during T2 state? T2 state la enna nadakkum? Any idea? What about the status of ALE during T2 state? During T2 state, what about the status of ALE? Memory nama address பண்ணியாச்சு கரெக்ட்டா. Higher order address line la higher byte of the address is available. Lower order address, it is available in the latch now. Okay. So during T2 state, ALE goes low, RD bar goes low. Very good. Correct? ALE low lay maintain agudhu. Fine. IO/M bar, it is maintaining low. Read bar enakku enna agudhu paru. It is getting activated during T2 state. Correct? Once it got activated, memory read bar signal is also generated. So the 8-bit data from the memory is available in the data bus now. Fine. During T3 state, that particular data is getting stored into the specified register internally. In the register and the data pool, store item. So how many T state? it takes for memory read operation in total how many T state? 3 T state. What about the number of T state for opcode fetch machine cycle? Yes, 4 T state. Very good, very good. Okay. See whether memory read machine cycle only happen to execute the instruction. Memory read cycle mattum nadanda or instruction execute aga mudiyuma? Or memory read cycle can be a part of an instruction cycle? Which one is the correct answer? Yes, memory read cycle can be a part of an instruction cycle. Okay, இது மட்டும் ஒரு instruction execute ஆகிறதுக்கு உண்டான சைக்கிளா இருக்க முடியாது. Fine. Yes, but all instruction cycle mandatorily must have which one? Mandatory ஒரு cycle கண்டிப்பா நடந்தாகும். Yes, opcode fetch machine cycle must be the first machine cycle of any instruction cycle. எந்த ஒரு instruction cycle எடுத்துட்டாலும் கண்டிப்பா opcode fetch is the first machine cycle takes place. Fine. Is it clear for everyone? Yes, fine. Yes, fine. Okay. Next, we will go with memory write cycle. I'm going to give seminar for some of you people. Okay. So memory write cycle நான் நடத்த போறதில்லை. Memory read cycle I have handled. Okay. So during first clock cycle, PC plays the address. Okay. Activates the ALE signal. So the lower order address will get latched. So then it sends the following status signal. Okay. During the first T state. During the second clock pulse, so the lower order is available in the latch. Okay. After the first T state, so AD7 to AD0 is now can be used for data. So MUP activates the read bar signal. The data from the memory location is placed on the data bus. The MUP reads the operand from the data bus and places it in the appropriate register. That happens in the T3 state. Okay. I want to tell you one thing. Okay. Note nu potu eludhi vechukonga unoda material la note nu potu eludhikonu. Okay, kindly make it as note. Okay, we have told one control signal. Do you remember? We have told one control signal used for speed synchronization. Do you remember that signal? Yes. Very good, Anthony Surya. Ready signal. Actually, என்ன பண்ணோம் அப்படின்னு பாத்தீங்கன்னா processor during the T3 state it will check the ready signal. நல்லா கவனிக்கணும். இதை நம்ம மென்ஷன் பண்ணல. இந்த machine cycle and timing diagram is a typical one. Okay, opcode fetch நம்ம சொன்னது typical one. Okay. On every T3 state of the machine cycle, okay, opcode fetch machine cycle or a memory read cycle. Memory read னு சொன்னோம்னா second T state. Okay. During the opcode fetch operation, during the T3 state, it will check the ready signal. Okay, and the ready signal namakku active irundha mattum da it will do the data transfer operation to the corresponding register or instruction register. Otherwise, the processor enter into wait state. Okay, alla purinjikano nama sollirukkiradhu the minimum duration for a opcode fetch operation that we are teaching. Okay, in some cases நமக்கு டிவைஸ் ரெடியா இல்லை அப்படின்னா T3 ஸ்டேட்ல எனக்கு என்ன ஆகாது, டேட்டா காப்பி ஆகிறதுக்கு பதிலா ப்ராசஸர் வந்து என்ன ஆகும், வெயிட் ஸ்டேட்டுக்கு போயிடும். ஃபைன். உங்களுக்கு எக்ஸாம் பாயிண்ட் ஆஃப் வியூல நம்ம ஆப்கோட் ஃபெச் மிஷின் சைக்கிள்னு கேட்டா அந்த டயக்ராம் நம்ம என்ன டிஸ்பிளே பண்ணணுமோ அதை வரைஞ்சிக்கலாம். ஃபைன். வெயிட் ஸ்டேட் அதில் நம்ம மென்ஷன் பண்ணல. ஆக்சுவலி டியூரிங் த T3 ஸ்டேட் ஆஃப் த மிஷின் சைக்கிள் the processor check the ready pin. If the ready pin is 1 logic, if it is high logic, that means the device is ready for read or write operation so that it can transfer the data. Otherwise, the processor enter into the wait state till the ready signal become active. Is it clear for everyone? தனியா நோட் போட்டு எழுதி வெச்சுக்கோங்க. For your understanding I am telling. Okay, சிலருக்கு டவுட் வரலாம் இல்லையா, ரெடி சிக்னல் இங்க எங்கேயுமே இன்வால்வ் ஆகலையா சார் அப்படின்னு. If the ready signal is low, that indicate the device is not ready. Correct? Okay, fine. So regarding memory read machine cycle, 3 T state. During first T state, send the address. Second T state, enable the read signal so that the data is available in the data bus. The third T state is copies the data from the data bus to the corresponding register. That's all. Okay. So during the T3 state, it deactivates the RD bar signal also. So this happened during the memory read machine cycle. Okay. So next we will go with the timing diagram of IO write machine cycle. Okay. So here you can see 2 signals are additionally added here. Rendu signal inga additionally add பண்ணிருக்கோம். என்னன்னு பார்க்க முடியுமா? Yes. IO write machine cycle நான் கொடுத்திருக்கேன். IO read machine cycle. I am going to give seminar to some of you. Okay. Yes, write bar signal here we mentioned. Actually, inge vandu read bar signal, it is not going to play anything. Fine. As it is IO write machine cycle, RD bar memory read bar is going to be inactive. Adha kaamikradhukaga da idiyu include பண்ணிருக்கோம் the timing diagram. Actually, these 2 signals are not going to involve during this operation. Fine. So as usual, processor has to send the address of the device. Okay. So what about the address of the IO device? Memory sonna 16-bit address sonna. What about the address of IO device? In out instruction use பண்றப்ப we used 8-bit address. Correct? Yes. So the lower byte, sorry, it is going to be only 1 byte. Correct? The address is going to be only 1 byte. That means the 1 byte address is going to be passed on the higher order address line as well as the lower order address line. Okay. So இங்க நம்ம வரைஞ்சிருக்கோம், அது தெரியல நமக்கு, ஃபுல்லா ரிவீல் பண்ணா தெரியும். Yes, port address. Correct? The 8-bit address is also transferred through higher order bus as well as the multiplex lower order data bus. Fine. ரெண்டு பஸ் வழியாவும் நமக்கு என்ன ஆகும்? The 8-bit address is set. Fine. ALE is getting active. Fine. Now, what about the status of IO/M bar? You can see in the diagram. What about the status of IO/M bar in this diagram? Can you type it in the chat? Yes, it is maintaining high. What it means? The current operation done by the going in the processor is IO related operation. It is communicating with IO device. So IO/M bar goes high. Read bar is inactive. Memory read signal is also inactive. Write bar is inactive. So IO write bar is also inactive. Fine. The status signals are 1, 0, 1. Correct? It is IO related operation. 0, 1 means write operation. Correct? S1, 0, S0, 1 means write operation. So IO write cycle. So the status signal indicate which type of machine cycle is going now in the processor. Okay. Which type of operation going inside the processor. That is indicated by the group of status signal. Fine. Okay. See, during the second T state, what happened? The bus got restated for some time. As it is write operation, from where the data is coming? Write operation enga data poganum? From processor to IO device or from IO device to processor? What about the direction of operation? Yes? Any idea? Data எங்கிருந்து எங்க போகணும்பா? Write operation அப்படின்னு சொன்னா. Yes, processor to IO. Very good. Processor to an output device. Correct? So you can see. What about the content of the AD7 to AD0 during T2 state? Accumulator content. Whatever present in the accumulator, it is available in the data bus now. What about the address? It latched into the latch. Correct? During the first T state itself, the 8-bit address is getting stored into the latch. Clear? But still, the same address is available in the higher order address line also. Okay. So still RD bar, memory read bar signal is inactive. Write bar and IO write bar signal are active. Correct? See, write bar signal getting low. IO/M bar is 1. So IO write signal got enabled. So during this time, the accumulator content is placed on the data bus. Correct? For data bus la enna irukum? Accumulator content. Correct? During the last T state, it will get stored into the respective or it is getting written into the output device. The output device la poi the addressed output device adha poi data vandu store aayidum. That's all. It is written to the IO device during the T3 state. That's all. So after return, write bar signal also become inactive. So 3 T state for IO write machine cycle. Fine. So now can you people type it in the chat? What about the number of T state for IO write operation? What about the number of T state for IO write operation? Yes, 3. Can you people imagine what about the number of T state for memory write operation? Memory write operation. How many T state it is going to involve? Okay, how it is 4. Memory read 3 dana nama sonnom, correct? Memory read ku 3, correct? Fine. See, next class probably coming session lab session irukum. Probably Saturday we will have seminar on the remaining thing. Okay, memory write ku IO read ku நம்ம என்ன பண்ணலாம்? 2 people I will assign and give seminar. Okay. So it also takes place in 3 T state only. Okay. Memory write அப்படினு சொன்னாலும் 3 T state தான். IO read அப்படினு சொன்னாலும் 3 T state தான். Totally I have told you 5 machine cycle. Opcode fetch, memory read, memory write, IO read, IO write. Correct? This opcode fetch மட்டும் 4 T state. Okay. Whereas the remaining memory read, memory write, IO read, IO read. It takes 3 T state only. 3 T state only. Fine? Yes. Is it clear? Is it clear now? Okay. One more point I want to tell you. At the end of an instruction cycle. Okay. Instruction cycle oda last clock pulse. Every instruction cycle's last T state, the processor check for interrupt. Okay. Processor enna pannum? Interrupt vandirukka illaiyaன்றத the last T state of every machine cycle. Sorry, every instruction cycle, not machine cycle. All the instruction cycle. At the end of all the instruction cycle, that means last T state of all the instruction cycle, it checks for whether any interrupt occurred or not. Okay, so in the point to note panni vechuko. Fine. Okay. So IO write machine cycle enna nadakudhu? We are assuming IO write machine cycle thaniya nadakadhu. Fine. Out P8 instruction, we are considering out P8 instruction. Okay, so out P8 instruction abdin sonnomna, it is 2-byte instruction. Okay, the opcodes are D3 and D3 comma P8, 8-bit address. I have typed in the chat, kindly refer it. Out, say for example, out 40 abdin vechikalam, out 40 abdin vechikalam, out 40H. I am considering this as an example. Okay, so D3 40, D3 40. These are the opcode. So out 40 abdin sonnomna, D3 is the opcode for out instruction, and 40 is the address. Correct? Okay. So in the particular instruction execute agumna, inik enna nadakkum parunga. First cycle kandipa enna irukanum? In machine cycle 1, enna agum? The opcode for out instruction is fetched. Correct? So oru machine cycle mudinjiruchu. Correct? Out P8 instruction execute aganum appadina enna machine cycle la nadakkum parunga. The first machine cycle must be opcode fetch machine cycle. Okay. Now the processor know what? It has to write a data from accumulator to a device. Correct? Whether it know the address now? Carefully observe what I am saying. D3 என்ற opcode processor read பண்ணியாச்சு. It fetches the opcode D3. Correct? For out instruction. Now after decoding, the processor know it has to transfer a data from accumulator to an output device. Whether it know the address? D3 என்ற opcode எடுத்துட்டு போயிட்டு decode பண்ணா அதுக்கு என்ன தெரியும்? what operation it has to do to write the content from accumulator to an output device, correct? Whether it know the address of the device. Address தெரியுமா இப்போ ப்ராசஸருக்கு opcode மட்டும் தானே எடுத்துட்டு போயிருக்கு. Definitely no. To read the address available in the memory, what it has to do? Any idea? First byte எடுத்தா அது பேர் opcode fetch. Next byte என்னது? It is an 8-bit address. What it has to do? And the address processor என்ன பண்ணணும்? To execute the particular operation, address fetch ன்னு சொல்ல மாட்டோம், memory read ன்னு சொல்லுவோம். Now you people understand memory read அப்படின்னா புரிஞ்சுதுங்களா? Apart from opcode, anything from opcode, if it is reading from the memory, that we call it as memory read. அப்ப first mission cycle opcode fetch அப்படின்னு சொன்னோம். What about the second mission cycle? What about the second mission cycle? What about the second mission cycle? First mission cycle opcode fetch, very good. The second mission cycle is memory read mission cycle, correct? 8-bit port address is read from the memory, correct? Memory lende 8-bit address read பண்ணியாச்சு. Now it know what it has to do on what device it has to perform the write operation. Fine. What about the last mission cycle? What about the last mission cycle now? Now it has to write a data to where? An IO device. So what mission cycle has to happen? See, memory lende opcode fetch பண்ணியாச்சு. Fine. Next memory read cycle use பண்ணி address read பண்ணியாச்சு. Fine. Yes, very good Anthony Surya. IO write cycle. The last one is IO write cycle. Correct? இல்ல வேற யாருக்கா டவுட் இருக்காப்பா? So now you people can understand ஒரு instruction execute ஆகிறதுக்கு minimum one mission cycle involve ஆயிருக்கும். That is opcode fetch cycle. Fine. So இங்க நீங்க சொல்ல முடியுமா? What about the timing of fetch operation? Fetch cycle oda duration என்னன்னு சொல்ல முடியுமா? In terms of t state? Yes, very good. 4 t state. For execution ஒரு memory read cycle, ஒரு IO write cycle. ரெண்டும் சேர்த்தா தான் execution, correctா? Yes, very good Anthony Surya. 6 t state. It's not 3. Correcta? Mission cycle 2 and mission cycle 3 for execution. Mission cycle 1 for opcode fetch. That's all. So totally how many t states involved now? Totally how many t states involved now? For executing the instruction out PA, very good, 10 t state. Very good, very good. Super. Okay. So during T1 state, MUP activates ALE signal and plays the 8-bit port address. Okay, our peripheral device. IO/M bar becomes high to indicate the current operation is IO operation. The 8-bit data from accumulator is placed on data bus during second T state of mission cycle 3. MUP activates write bar signal to perform the write operation. The 8-bit data on the data bus is transferred to the IO device address. That's all. Okay, so totally it takes 3 T state for IO write cycle, which is the third mission cycle of out PA instruction. That's all. Okay, so that's all about the IO write mission cycle. So after writing, write bar signal gets deactivated. That's all. Okay, so the timing diagram of a 2-byte instruction MVI R, DA. Anybody can say how many mission cycle first involved in this particular instruction cycle? MVI R, DA. MVI R, DA. We can consider MVI A, 77H. We can consider this example. Can you write the opcode for these instructions? MVI A, 77. Can you write the bytes for this instruction? MVI A ka opcode enappa? 3H. The data is 77H. Correct? These are the 2 bytes for the instruction MVI A, 77H. Is it correct or not? Okay. On seeing this, you people can say how many mission cycle must takes place? Obviously, what about the first mission cycle? First mission cycle kandipa enna irukanum? Kindly type it in the chat. See, yes, opcode fetch mission cycle. Okay, correct. Very good, very good. Opcode fetch paniyachu. After fetch the opcode, at the end of T4 state, it knows what it knows. It has to get the data from the next memory location to accumulator register. So what it has to do next? Very good, memory read cycle. Correct. So opcode fetch, that is one mission cycle. Memory read, that is another mission cycle. Correct. After read the data 77, where it has to store? It has to store to accumulator. Fine. At the end of memory read cycle, Anthony Surya, memory write cycle inge varadu. Where it is going to write the data 77. Where it is going to store the data 77. Memory lend read pannadukapram, it has to place it in accumulator. Whether accumulator is internal source, whether accumulator is inside the CPU or outside, yes, internal operation. So internal operation na enna sollirkom, with no time the operation will be completed. That means it doesn't need any other cycles. Clear? So now you can realize, for executing MVA R, D8 instruction, it need opcode fetch mission cycle, then memory read mission cycle. This two mission cycle it need. So totally it need 4 plus 3, 7 T state to execute the instruction MVA A, 77H. Correct? Is it clear now? See, நீங்க imagine பண்ண வேண்டியது என்னென்னலாம் பண்ணணும் ஒரு இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் ஆகணும்னா ஆப்கோட் எடுக்கணும். ஓகே, ஆப்கோட் எடுத்தா எனக்கு என்ன தெரியும்? அக்குமுலேட்டருக்கு ஒரு 8-bit டேட்டாவை இமிடியேட்டா மூவ் பண்ணணும். That's all the processor know. But data is available in the next memory. So what it has to do? It has to read the memory one more time. So memory read cycle வேணும். That's all. Clear? Is it clear for everyone? Is it clear for everyone? Yes, fine. Now, let's answer for this. Move A, B. What about the size of the instruction? How many bytes it will occupy? That's what I'm meaning size. How many byte instruction? Move A, B. Yes, very good. 1 byte. How many mission cycle it takes place? How many mission cycle? Not T state. How many mission cycle? எத்தனை மிஷின் சைக்கிள் இன்வால்வ் ஆயிடும்? நம்ம எக்ஸாம்பிளே அதான் நடத்தணும். கரெக்ட்? See, move A, B க்கு ஒரு opcode கண்டிப்பா. கரெக்ட்டா? So அதை fetch பண்ணணும். That is the opcode fetch mission cycle. What about the operands? Internal operand. So execution doesn't require any more timing. Correct? So one mission cycle. Very good. What about the name of the mission cycle? What about the name of the mission cycle? Yes, opcode fetch. Very good, very good. How many T state it takes place? Yes, very good. 4 T state. Now the question is, if the microprocessor is operating at 3 megahertz, how much time it takes to execute the instruction move A, B? That's my question. The processor operating frequency evlo? FOSC is equal to 3 megahertz. Okay, time period to execute move A, B instruction. என்ன வரும் சொல்லுங்க பார்க்கலாம். Shivakumar typed 0.33 microsecond. That is the time period for 1 T state. Correct? I am asking. Yes, very good, Danya. Yes, 4 into 0.33, or simply you can write 4 into 1 by 3 mega. Yes, 1.32 microsecond. Okay, 1.32 microsecond. Fine. Few of you are getting the answer as 1.33. That is also correct. Fine. நம்ம 0.33 நம்ம என்ன பண்றோம், ட்ரங்கேட் பண்ணிடுறோம் ரிமைனிங் டெசிமல் போர்ஷன்ஸ், ஐ மீன் ஃபிராக்ஷனல் பார்ட். கரெக்டா? ஸோ அதனால நமக்கு 1.32 சில பேருக்கு வந்திருக்கும், 1.33 வரும். You should not mention with capital M Dixon. You can simply type micro. Okay, fine. What about the next instruction? How many byte it occupies? How many byte it occupies? The next instruction, MAC, 07H. 2 byte, very good. How many machine cycle takes place? How many machine cycle takes place? 2 machine cycles, very good. What are the machine cycles? To read the opcode, it takes 1 machine cycle. To read the data, it takes another machine cycle. So, opcode fetch, to fetch the opcode, memory read, data 07 and C register to move pandradhukku, it takes another cycle. Fine. In total, how many T state it takes? For opcode fetch 4T, for memory read 3T, totally 7T. What about LDA instruction? Third instruction. How many byte instruction? How many byte instruction? LDA 8100. Yes, very good. 3 byte instruction. Very good. What about the number of machine cycle? Here I will know how much you understand the concept. நல்லா யோசிச்சு பதில் சொல்லுங்க, எத்தனை மிஷின் சைக்கிள் வேணும்? நல்லா யோசிச்சு சொல்லுங்க. opcode 1 byte, கரெக்டா? Then lower byte of the address, then higher byte of the address. Correct? நல்லா யோசிச்சு ஆன்சர் பண்ணலாம். Number of machine cycle takes place in LDA instruction. No, Shivakumar, it's not 2. It's not 2. Say for example, LDA instruction, and the instruction I type on the chat la check பண்ணிக்கோங்க. LDA 8100H. இது எப்படி நம்ம எழுதுவோம்? 3A opcode for LDA 00 lower byte, 81 higher byte. Will be mentioned like this. Kindly refer the chat. Correct? So the first cycle kandipa opcode fetch. Correct? Second cycle என்ன பண்ணணும்? Lower byte of the address read பண்ணணும். Third cycle higher byte of the address read பண்ணணும். Correct? Anthony Surya, 3 machine cycles are correct? LDA opcode கடிச்சிச்சு, lower byte எடுத்தாச்சு, higher byte எடுத்தாச்சு. Very good Shivakumar, very good Danya. Can you unmute and tell Shivakumar how it is 4 machine cycle? 4 machine cycle is the correct answer.
Sir, first opcode fetch, sir.
Very good. Opcode fetch. Next.
Lower address and higher address.
Yes, lower byte of the address it has to read. So one memory read cycle. Higher byte of the address it has to read. Another memory read cycle. What about the last machine cycle? Till the operation is not complete, correct? என்ன பண்ணனும்? Address கிடைச்சாச்சு. To perform the operation, what it has to do? 8100 ல இருந்து டேட்டாவை எடுத்துட்டு வரணும், கரெக்ட்டா? So it need one more machine cycle to read the data from the memory location, correct? Opcode fetch, memory read, memory read, memory read. So how many T state now? Can you type it in the chat? Very good, very good. How many T state in total? 4 plus 3 plus 3 plus 3. Very good. 13 T state is the correct answer. Fine. Similarly, what about STA? What about STA? STA instruction 3 byte. Correct? LDA 4 machine cycle சொல்றதுனால STA 4 machine cycle சொல்லலாமா? Yes or no? Yes or no? What about the number of machine cycle in STA instruction? STA 9000H. Fine. 32H, 00H, 90H. Fine. So with this slide, we will stop today's session. Okay. probably. 3 cycle dana. Is anybody saying 4 cycle? Shivakumar typed 4 cycle. Yes, very good Shivakumar. Very good. Anthony Surya, how it is 3 cycle? Shall we go with 4 cycle is my answer and Shivakumar answer. The first one is opcode fetch. The second one is memory read. Lower byte of the address read paniyachi. The next one is higher byte of the address we have read. Fine. What about the last mission cycle? See, STA means what it has to do? It has to store accumulator content to a 16-bit address. So it need address. To get the address, it need 2 memory read. Lower byte of the address, higher byte of the address. Fine. The last one is memory write cycle to store the data from accumulator to 900H. That's all. So here also it is 13 T scale. Okay. So the remaining we will continue in the next session. Thank you. I will stop the recording now.